Yo, pre-calculus, what's going on? This is Mr. Taryn rocking with you today again. This time we're looking at 2.2, part 2, and really we're going to focus ourselves with some more leading term test questions and also this idea of graphing polynomials just based on leading term test and multiplicity. Let's get after it. Here we go. So the objectives, same thing as last time, except that obviously we're not modeling real life data. We're not doing any of that this year. So here we go. Multiplicity, all that means is it's the number of times that a zero is repeated. And when we're talking about a zero, we're talking about like if we factor something down or we use second trace zero features on our calculator. So when you factor something down, say you have something like you factor something down, you get x minus 2, and you have 3 of those. Well, that x minus 2 factor, when we use zero product property, we would set it equal to 0, and so x would equal 2. However, x would equal 2 with a multiplicity of 3, since there are 3 repeats. That's all multiplicity is. However, you should also know that if the multiplicity is odd, then the graph is going to actually cross the x-axis. So it would look, something like that, right? If the multiplicity is even, then please note that the graph will touch but not actually cross the x-axis. So here's an example of that. If I had an even multiplicity, would be something maybe, say it crosses here or whatever, but maybe it'd be something like, something like that. See how it's just barely touching? This would be an example of an even multiplicity. So knowing what we know about leading term tests, knowing what we know about finding zeros, we can actually come up with a decent sketch of a graph without having to ever plug it into our calculators. So here is kind of our first example. So it wants us first to apply leading term test so that I can figure out what the end behavior is. Now, excuse me, I could spend a whole lot of time multiplying all these together. I'm not going to. What I know is if I have this x minus 2 squared, really that's going to be x squared minus 4x plus 4. And I still have this 3x plus 1, and I still have this x. Now I could go ahead and still multiply these up, but really what I'm concerned with, I know that I'm eventually going to multiply this x by this 3x and also by this x squared. So all these x's eventually are going to get multiplied together. So my leading term, if I have an x squared here, I have another x here, and I have another x here, that's a total of x to the 4th. If you don't believe me, you can multiply it out. Also, 3 is the only coefficient I have when I multiply those, so I know my leading term is going to be 3x to the 4th. Knowing that I have a positive leading coefficient and an even degree, I know that my graph will look something like that. So I could say the limit of f of x as x approaches negative infinity will be positive infinity. Also, the limit of f of x as x approaches positive infinity is also equal to positive infinity. So that's the first part of this example, is figuring out what your leading term is from multiplying all this together, then using leading term test to define your limits. You're not going to stop here, though. We also want to draw an actual sketch of my graph. So I know right here, if I use zero product property, let's use green. I know that x equals 0. I know that 3x plus 1 equals 0, and I know x minus 2 equals 0. So I know x equals 0, x equals negative 1/3, and x equals 2 with a multiplicity of 2, since there are 2 of them. Knowing that and knowing my end behavior, I can kind of sketch a graph here. So if I just draw a quick little I know my zeros are going to be at 0, negative 1/3, and 2. So say this is 1, 2, 3, 4, 4, negative 1, negative 2. So again, here's my 0 at 0, 0. Here's my 1 at negative 1/3, and then I have another 0 at 2. I know that this 0 at 2 is going to touch. It's not going to go all the way through because I have an even multiplicity. I also know from the last slide that my end behavior says it's going, I'm going to have a graph that looks something like that. So I'm going to start this one out here going somewhere out here. And I know these are odd multiplicities, so I know that they're going to cross all the way through. And then I know at this 2, it's not going to cross. It's going to just touch and go back up. So my graph would look something like that. All I really care about when you do these graphs is I want to see these zeros, and I want to see if it's an even multiplicity, it should just touch. If it's an odd, it should go through. But that's pretty much it, and I think that's it for this entire section. Really, this entire section was just using, your multiplication to find leading term test, to find end behavior, being able to factor and find your zeros, and then being able to graph them. Here's just another kind of picture of what we just went through. But that's pretty much it. So hopefully this all makes sense. Again, if you have any questions, ask your teachers. Tearing out.